Again, we need to find the complete integral of this given equation. So we are going to use the Charpit's method over here. First, we need to take our f, and I'm taking that to be this left hand side. And now we have to use the Charpit subsidiary equations for this. Okay, dx divided by fp. Derivating f with respect to p, what we get? Minus x square plus q. Right? So writing here minus x square plus q equals to dy divided by derivating f with respect to q. What we get? Minus 2xy plus p. So this is minus 2xy plus p. And then dz divided by p multiplied with fp. This is already fp. We need to multiply p with this. We get minus px square plus pq, right? Plus q multiplied with fq. So this is pq minus 2qxy. So these two becomes twice of pq. So I'm writing this. So this is minus px square plus twice of pq minus 2xy pq. That's it. Okay, dp divided by minus of fx. Derivating f with respect to x, what we get? We get twice of z minus 2px minus 2qy, right? And this is added with p multiplied with fz. Fz is 2x. So adding fx plus p times fz. P times fz, that is 2xp. So when we add these two cancelled out and we get 2z minus 2qy. Taking minus 2 outside, right, equals to dq divided by negative of fy. Derivating f with respect to y, what we get? Very carefully, it is minus 2qx. That's it. Okay. Plus q multiplied with fz. Q multiplied with fz. Fz is 2x. So these two cancelled out. This is 0. So we have here 0. And now we need to choose those ratios for which we can get either the value of p or q or the relation between p and q. So what is the easier way to solve the ratios? So for that, let me choose. So it is very easier to choose dq, right? So from here we get dq to be equal to 0. That is q is constant. Let's take that constant to be a. You can also equate the single ratio to be equal to 0. Either you can equate any two ratios or you can also equate one ratio to be equal to 0. So from here I get q equal to a. Okay, one more. So there is no need to choose any other ratio because already I get the value of q, and now I'm going to substitute this value of q over here to get the value of p. So already we are having the value of q to be a, where a is constant, and now to get the value of p we are going to substitute this value q in the given equation. So when putting q equal to a, we get 2xz minus px square minus 2axy plus pa equals to 0. Taking p common, we get a minus x square, and taking the remaining terms to the other side, we can take 2 common, axy minus xz. We can also take x outside common. Okay, writing here 2x into ay minus z, or p is equal to 2x into ay minus z divided by a minus x square. Let's take negative common from the numerator. This is z minus ay, and let's take x common from the denominator. It looks good if we have x square minus a. X square to be the positive term. It's your choice, right? Okay, next we need to use the equation dz equal to p dx plus q dy. To get the complete integral, we need to get the value of z. Let's put the values of p and q over here. What is p? It is 2x into z minus ay divided by x square minus a dx plus q is a dy and here dz. Let's take a dy to the other side because we are having z minus a, right? So I am going to take this bracket to the denominator of this. And now we can easily integrate these two. From here, I can write this numerator to be derivative of z minus ay. Right? And here, this is nothing but log of x square minus a plus the constant b. Let me take the constant to be log of b. And from here we get it is log of z minus ay equals to log of x square minus a plus log of b, where this log of b is constant. By the property of log, it is x square minus a into b. Taking x square minus a to the denominator, it looks good, equals to b. So from here we are getting the value of z to be the complete integral of the given equation is the required complete integral. Alright, happy day.